So we've looked at the theory behind exponential growth and decay functions. So that is representing it as an e to the power of function. What I'm going to do in this video, I'm going to set you a few questions on this type of problem. I want you to watch the questions, pause the video, have a crack at them, and then come back and check your solutions with the working and the answers I'm going to show you after that. So here are the questions for you. First one, due to inflation, prices increase annually. The price P of an item after t years is given by the function P of t equals P naught e to the 0.05t, where P naught is the original price. If half a litre of milk costs 35p now, how much will it cost in 1 year? And the second part is how long it will take for milk to cost more than 50p. Second one's about a van hire company calculating the depreciation rate of a van using that formula Vt equals V naught e to the negative 0.16t. V naught's the initial price of the van. New van costs 18 grand. What's the value after 5 years? How much does its value fall by after these 5 years? And how long does it take for the value of the van to fall below 7 grand? So, pause the video and have a crack at these. Right, let's run through these questions and see how you got on. So, first one, half a litre of milk costs 35p now. How much will it cost in a year? So for this question, if you look at the formula, there's a couple of things we need to know. T is our time and P naught is our initial price. Well, it costs 35p now, so we know in this case that P naught is equal to 35. That's the first thing we have to identify. Second thing, we need to know T, what the time scale is like. So in this case, we know T is equal to 1. Once we've got these, we can plug it into the formula and work it through. Because what we know is we're looking for P of 1, and that's going to equal P naught, but we know that's 35 for 35 pence, times e to the power 0.05 times 1. Now anything times 1 is itself, so it's 0.05. Plug that in your calculator, and what you end up getting is 36.794, and then a whole spiel of stuff after that. Now remember, it's 35 pence. We don't have decimals when it comes to pence, so we have to round it and put it back into the scenario we want it. The 7 makes the 6 go up. So we know at the end of year 1, it's 37 pence. Alright, so 37 pence after 1 year. Second part is how long it will take for the milk to cost more than 50 pence. So what we know in this case is that P of t is equal to 50p. We want to know when the price is equal to 50 pence or more. So we have to set a function equal to that. So what we know then is we want to set P naught e to 0.05t equal to the 50p. Now we know what P naught is. It's the same starting price in the first one. So it's 35e to the 0.05t equals 50. Now it's just a bit of algebra now to try and solve this type of question. Shift the 35 over, and we get e to the 0.05t equals 50 divided by 35. Now remember what we said in the theory video, to get rid of the e here and we shift it across here, so we're just left with the 0.05t, we take log to the base e of the 50 over 35, which remember is the equivalent of ln on your calculators, 50 over 35, so natural logarithm. We can then solve this like we would a normal equation, divide by the 0.05, so t equals 1 over 0.05 times your ln of 50 over 35. Stick that in your calculator, and what you end up getting is 7.133 ... Now, looking at this, that says time is equal to 7.1 years. Great. So 7 years it will be less than 50 pence, more than 50 pence. Well, no, that's not right. It's 7.1 years, and we're measuring it in full years. Now, I know logic dictates that when we have a 1, we round down. We keep the number as it is, we don't go up. However, think of the scenario. When it costs more than 50 pence, it'll be after the 7th year, but before the 8th year. So what we then say is, therefore, t equals 8 years for the cost over 50p. It has to be the 8 years. Alright, we can't have it in the middle of the year, and we can't go down because it's not hit that point where it's above 50 pence yet. Alright. Second question was about a decay problem. So depreciation of a van value. This is the function to use. V0 is the initial price. 3 questions here. So first one, new van costs 18 grand. What's the value after 5 years? Again, with this function here, key things we need to know are the t for the time and the V0, the initial value. Well, we know the initial value, V0, is 18 grand, 18,000. And we know for this one, we want the time t equals 5. So what we can then do is just plug it all in. So we want to find V of 5 equals 18,000 times e to the power of negative 0.16 times 5. So it looks like a lovely bit of maths there. Plug that in your calculator. What you end up getting is 8,087.9213 and then a whole spiel of stuff. And again, put it back into the scenario. So it's money we're after. 2 decimal places for money. So the value of the van is £8,087.92. Question is, you could probably get away with rounding it to the pounds. £8,088 is what you could roughly say it's worth. What we then do is the second part is how much does the van's value fall by after the 5 years? So how much has it fallen from the start to that point? Well, to do that, we have to take the initial value and take off what it now costs. We then have to take off the £8,087.92. That should be a fairly straightforward calculation. Stick that into your calculator. £9,912.08. So that's what the value of the van has fallen by. So it's not what it's worth, that's what it's fallen by or decreased by. The last part is how long does it take for the value of the van to fall below £7,000. So again, it's similar to the first one. We know at this point, V of t is 7 grand. So we want to know at that point, when does it hit 7 grand and when does it get below it? So we have to set it up V0 e to the negative 0.16t equal to that. So we have to set up 18,000 e to the negative 0.16t equals that £7,000. And then it's a case again of jiggery-pokery to solve it. So it's e to the negative 0.16t, 7,000 divided by 18,000, that simplifies to 17 over 8. Negative 0.16t, again to get rid of the e on this side and shift it over here, we take our log to the base e again, of 7 over 18. Again, that's still the equivalent of ln, your natural logarithm, 7 over 18. Doesn't matter which version you use. This one's probably easiest to use in your calculator. We then divide by the negative 0.16 and we know t equals negative 1 over 0.16 times your ln of 7 over 18. Plug it in the calculator and what you get is 5.902 ... years. So 5.9 years is what it roughly takes. Now, that's when it hits it, but it's full years. So what we then have to say is rounding it appropriately for the scenario. We can't say it's 5 years because it's not falling below it then. So it has to be the next full one. So what we can then say is t equals 6 years for the value below 7 grand. So below £7,000. Okay. So we have to make sure we put it back into the context appropriately. Bear that in mind when you're doing it. It's logic. Alright, a question like this, yes, it's maths, but bits to do with your rounding can sometimes go against what you naturally think purely because of the logic of the scenario.